We're told that x follows a binomial distribution with 10 trials and a probability of success of 0.38. We want to find the probability that x is 3. The coefficient is 10 for the 10 trials, C3 for the 3 successes. We have 3 successes and the probability of success is 0.38. So we have 0.38 cubed. If the probability of success is 0.38, the probability of failure must be 0.62. Remember, the probability of success and failure must add to 1. If we've had 3 successes out of 10, we must have had 7 failures. We can calculate this and get 0.2319 correct to 4 decimal places. We now want the probability that x is 6. So we have 10C6. Remember, 10 trials and 6 successes. Probability of success is 0.38. So this is to the power 6. The probability of failure is 0.62. And if we've had 6 successes, we must have had 4 failures. And this is equal to 0.0934, correct to 4 decimal places. We now want the probability that x is between 3 and 6, inclusive. To do this, we need to work out probability that x is 3, add it to the probability that x is 4, and add the probability x is 5, and then add the probability that x is 6. We can just add them because, of course, they're mutually exclusive. We already know the value for 3 and 6, as these were the answers to part A and B. So we need to work out the probability x is 4. This will be given by 10 for the number of trials, C4 for the number of successes, times 0.38 to the 4, times 0.62 to the 6, which is 0.2487. The probability of x being 5 is 10C5 times 0.38 to the power 5 times 0.62 to the power 5. And this gives us 0.1829. So therefore, the probability of x being between 3 and 6 inclusive is 0.2319 plus 0.2487 plus 0.1829 plus 0.0934, and this gives us 0.757, correct to 3 decimal places.